So welcome to this latest video on 162 Maths, and in this video we'll be continuing with the theme of going through some higher GCSE mark questions taken from some past papers. And as always, there'll be a copy of the questions for you to download and have an attempt at, which I strongly recommend you do, so you can see how many marks on these questions you actually achieve before watching through this video as we go through the answers. Now, before we get started working through these questions, it's worth mentioning that it's really important that you do understand each of these topics before learning these questions. These are not questions that you'll understand the topic if you get them right. So if you're unsure about any of the topics you can see on the screen, then I strongly recommend you watch some of the lessons or revise your notes of these topics before attempting these questions. And again, all you need to do to access the lessons is just simply click on the link to the contents page of 162 Maths and find the lesson that you're looking for. So let's get straight into question 1. So question 1 reads that a company has 123 employees. Information about their hourly rate of pay is shown in the table below. The owner of the company uses the data to make two statements, and statement A says that over 30% of the employees have an hourly rate that is more than £17, and statement B says that the average hourly rate of pay is more than £20. Now for part A, it's asking us to show working that supports statement A. So for this, what we need to do is we need to find out how many employees are earning more than £17. Now, as you can see from the table that we don't have 17 as a start of a group. As you can see, we've got group data. So what we then can assume that with 14 and 20, that 17 is the middle number. So what we'll do is we'll just assume that half, because it's halfway, we'll assume half the frequency of that group is 17. So here, 16. So here we've got 16 of those, we've got 15 of those, and we've got 10 of those. So more than £17 per hour is going to be 16 plus 15 plus 10, which gives me an answer of 35.41. So then to work out the percentage, all I need to do is do the frequency of what I'm wanting, which is 41, over the total frequency, which is 123, multiply that by 100, and if I type that into my calculator, I get an answer of 33.3 recurring percent, which is higher than 30. Now moving on to question B, it says why might statement A not be true? And again, there's a couple of reasons which we could give that would be valid for the 1 mark for this particular question. So again, if your answer is different to one that I've probably written, then all you need to do is just simply check the mark scheme and see if they will give you the mark for it. But I would say one of the most common ones is that we've assumed that half of the 14 to 20 are earning more than £17, which might not be true. You might find that 32 may be more towards the £14 than £20. We could also say that we've not used exact values because we've used group data. Excuse my handwriting there. And you could also say something along the lines of that estimates were used. And like I said, there's quite a few possible reasons that would get you that 1 mark. Moving on to C, it says work out an estimate for the mean to support statement B. So for this, what we need to do is we need to work out the estimated mean. So in other words, work out the average from group data. Now, if you remember, the first thing we need to do is create a midpoint column. So midpoint between 10 and 14 is 12. Then we've got 17, then we've got 30, and then we're going to have 70. Then we need to create an FX column where we multiply the frequency by the midpoint, in which then I'm going to get 792, I'm going to get 544, I'm going to get 450, and I'm going to get 2486. And then all I then need to do is work out the total FX, which is going to give me actually no, I've messed that up, excuse me, there, that should be 700. And this value here will be 2486. So the estimated mean, this works for B, is going to be the total FX, which is 2486 over 123, which is going to give me an answer of £20.21. And again, that supports the statement because the statement says the average hourly rate is more than £20. So 21.21 is more than 20. It then says for question D, it says, why is the mean not the best average to represent the data? And again, several reasons which we could say for this one. Actually, this is C, not B, so D here. And again, you could say something along the lines of that the data is skewed, which basically means that it's more one-sided than not. So as you can see from the table, that there's more people earning less than half, well, less than 20 from the groupings than the high earners. You could say that the wages are closer to the minimum value than the upper value. You would say if the wages are more evenly spread, then you may find that the wages that are there are going to be equally. You could mention something about the groupings and the fact that the groups for the low end are quite narrow in terms of the range, but then when you get to the high end, it's got a class width of 60. So you've got, if I will look at the class width, I've got 4, I've got 6, I've got 20, and then I've got 60. And as you can see from the high earners, the class width is a lot bigger. So you could mention something like that. You could say that less than half were more than 20. So here you can see in terms of the people earning more than 20 was less. There's a 25 out of 123. So therefore, you could say as valid reasons as to why the mean is not the best average to use. In fact, what it would be the best average to use when your data is skewed is going to be the median. Then moving on to question 2, it says that a line A has an equation of y equals ax minus 1 passes through point 713. Line B has an equation of 5y minus 3x equals 4. Show that line A has a greater gradient than line B. So let me just zoom in so we can see it a little bit more clearer on the screen. Let's just shift it across. There we go. So here we've got line A and we've got line B. So to find the gradient, what I need to do is basically for line A is I need to substitute this coordinate into y equals ax minus 1 to find out what my A value is going to be. So what we're going to do is we're going to sub x equals 7, y equals 13 into y equals ax minus 1. Now if I do that, I end up with 13 equals a times 7 minus 1. So here I've got 13 equals 7a minus 1, which is 14 equals 7a. So a equals 2. So therefore the line of A, or the equation of A, is going to be y equals 2x minus 1, which has got a gradient of 2. Then moving on to line B, all I need to do here is a bit of rearranging to make y the subject so I can find out what the gradient is going to be. Now again, it's not essential for you to do that. If you can see it straight away, brilliant, fantastic. Just write down the gradient and compare the two. But I'm going to do a bit of rearranging. So here we've got 5y equals 3x plus 4, then divide by 5. So I've got 3x over 5 plus, oh, I don't know why I've put a couple of extra x's there, plus 4 over 5. And then, as you can see from the gradient of line B, that the gradient is going to have a gradient of 3 over 5. So here, the gradient is equal to 3 over 5. So as 2 is greater than 3 over 5, line A has a greater gradient than line B. Moving on to our third question. So it says work out the size of angle X. Now this is going to be basically a two-step trigonometry question because we've got right angle triangles and we have got sides and angles. So for this, the first thing I need to do is to find, now to work out X I need to know at least what two sides are. At the moment I only know one side, so the only side that's connecting the two triangles is this side here. So I need to find the length of that blue line. So if I take that triangle out, let me just do it in a different colour so it's a bit more obvious as to what I'm doing. Let's go for green. So if I take this triangle here, I'm just going to flip it on its side. So this here is 37, this side here is A, this is C, this is D. So I know that A to D is 4, and the side that I'm wanting to find is AC, which is this length here. So from this, what I need to then do is label the triangle. So that's H, this is going to be the adjacent. So which trig ratio uses A and H? Well, that's going to be cos. So I've got cos 37 equals, now I'm just going to call this X, and that's going to be the adjacent, so it's X over 4. So therefore X equals 4 times cos 37. Now typically most people would probably word that out as a decimal, which if I just type that into my calculator now, I get an answer of around about 3.194 blah blah blah. Now because I've not finished the question, I'm going to be as accurate as possible, so I'm just going to leave that length as 4 cos 37. So then if I take this triangle out, this triangle here of ABC, and I draw that out again, that this angle is what I'm trying to find. This length here is 9.3 and this length here is 4 cos 37, or 3.194. So again, labeling the triangle, I've got H, I've got O, so I'm going to be using sine. So I've got sine X equals the opposite, which is 4 cos 37, or 3.194, over 9.3. So that means that X is going to equal the inverse sine of 4 cos 37 over 9.3. And if I type that all into my calculator, I get an answer of 10.1 degrees, and that's to 1 decimal place. Now if you've not used the exact values, the mark scheme would allow any answer between 19.87 to 20.13 to 2 decimal places. So if you've used 3.194 or 3.19 or even 3.2, probably wouldn't go for 1 decimal place. I'd go a little bit one extra than however you want to leave your answer. Any answer between 19.87 to 20.13 would be give you the full marks. Moving on to question 4, it says to rearrange y equals x plus 8 over x. So here we've got a rearranging formula where we've got two x's on one side. So for this, what we want to do here is, if I just write out the question, is we want to take this x over to the other side. So what we end up with is xy equals x plus 8. So I've got x's on both sides, so I want to take this x over to the other side. So I've got x plus y, no I haven't, I've got xy plus x equals 8, and then I want to factorize, so I've got x times y minus 1 equals 8, and then take this bracket over to the other side, so I've got x equals 8 over y minus 1. Now depending on the order of how you've done it, another possible way of writing the correct answer is to write minus 8, 1 minus y. So if you wrote that, that would be absolutely fine to get you full marks, but just remember your y doesn't look like a 9, which is what potentially it could look there. So yes, any of those two would be absolutely fine as the correct answer. Moving on to question 5, it says here are the first 4 terms of a quadratic sequence, and it says work out the expression for the nth term. So again, for this, and it's worth 4 marks, so it's going to be generally a few steps on this. So if I just write down the numbers first, so the first thing we need to do is find the double difference. So here we've got a difference of 17, then we've got a difference of 27, then we've got a difference of 37, which then gives us a double difference of plus 10. So that means that 5n squared is going to be in the formula. Now if I work out what 5n squared is, so if I just write what n is, 3, 4, 5, I don't need to go to 5 actually, so let's just do 4, and work out what 5n squared is. So 1 squared is 1 squared is 1, times 5 is 5, 2 squared is 4, times 5 is 20, 3 squared is 9, times 5 is 45, and 4 squared is 16, times 5 gives me 80. Now if I write down what the original sequence is, which is 3, 20, 47, and 84, what I now need to do is I need to work out what the difference is between 5n squared and the sequence. So here you can see the difference is minus 2, then it's 0, then it's plus 2, then it's plus 4. So what I now need to do is to find the nth term of the difference, because so far what I've got is I've got 5n squared plus the difference is the nth term. So what I need to do is I need to find out what the nth term is for the difference. So looking at the green, I've got a difference of plus 2. So that means 2n is going to be in the formula. Now how do you get from 2 to minus 2? Well, I need to take away 4. So the difference therefore is equal to 2n minus 4. So if I now substitute that into this, I get my final nth term formula. So the nth term formula is going to be 5n squared plus the difference, which is 2n minus 4. Moving on to question 6, it says Magana decides to put £500 into an account that pays a compound interest. She wants to have at least £560 in her account after 3 years. Work out to one decimal place the minimum annual interest rate she needs. So for this, for compound interest, if you remember the formula, it's the original amount that you're investing, which is £500, multiplied by the decimal multiplier, which we don't know, to the power of how many years it is, which in this case is 3. And for this, we want this value to be at least £560. So it needs to be greater or equal to 560. So from this, what we now need to do is solve this. So here, if we take the 500 over to the other side, so we end up with x cubed is greater or equal to 560 over 500. And if I just type that into my calculator, 560 divided by 500 gives me 28 over 25. And then I want to find out the value of x, so what I then do is cube root 28 over 25, in which x needs to be, and if I just type that into my calculator, 1.03849 blah blah blah. So the interest rate needs to be greater than that or equal to. Now it says to one decimal place, so to one decimal place for the percentage, if I multiply that by 100, well, from this we should be able to work out what the interest rate is going to be. So the answer then to one decimal place is going to be 3.9%. Now again, if you're not sure, I strongly would recommend sticking in the calculator. So if I load up my calculator now, which hopefully does load up in any second now. So here I've got 500 multiplied by 1.038 to the power of 3. And one will see if this is more than at least 506. Now you can see it's just shy of about 81 pence. So therefore it must be 1.39. So if I just do 500 multiplied by 1.039 to the power of 3, you can see that it just manages to creep over that 560 mark. So there we go. So that's why the answer then is 3.9%. Moving on to our last question, it says an approximate value of a root of an equation x can be found using the iterative formula of whatever it is. It says the starting value is x1 equals 4. Work out the values of x squared and x cubed. Now this is definitely going to be on a calculator paper, so if I get my calculator back up. Now to enter this on your calculator, all you need to do is press 4 for the first value, press equals. The next what we'll then do is enter this formula. So if I press, and then just move this across over here. So if I press shift and then the cube root function, which is there, and I'm going to enter this formula as follows. So I've got 5 bracket and close bracket squared minus 2 bracket and bracket minus 3. Now if I press equals, that's going to give me my x2 value, which if I write down, now there's no indication about how many decimal places they want x2 written to, but I'm just going to simply, oh that's annoying, it's just come off the screen. So that gives me a value of 4.10156593. Then if I just do all of that again, so let me just So press equals, that gives me my x2 value. Press equals again, this gives me my x3 value. So here it's going to be 4.177641648. And again, if you want to give your rounded answer, but you get 1 mark for each of those values being correct. It then says, by continuing the iteration, show that the value of x is more than 4.25. So if I get my calculator still on my screen, and if I just keep pressing my equals number, what I'm wanting is eventually that's going to stop changing. Now again, this is going to definitely annoy people in the exam room if you're doing this in the exam. Try and do it quietly. But as you can see, it's going to try to 9 decimal places, it stops there. So you can see that as x tends towards as we get to the infinite term, we can see that it becomes 4.388489747, which is more than 4.25. And there we go.